All right, guys. So today on March 18th, we are going to be going over yesterday's problems, the practice problems that we hadn't finished from the day before. And then after that, we're going to work more on the main program loop, starting with scaffolding all the possible actions that people can take when they're logged into the application. So we'll see how far we get today. We'll start off by just setting up the framework of function calls here, trying to condense things as much as we can to keep the main function as short as possible, given the logic that we're doing here. So there'll be a lot of basically, if this user is this kind of person and the action that they input on our command was this, then do this, call this function. And we'll have all sorts of logic like that. But before then, we're going to go ahead and go through the practice problems that we had left. So yesterday, we had worked through this one here, checking if a store has a valid store owner given a store name input. So, we had two separate read blocks where we were reading information from our CSV files that we're using to store data. So we did that one yesterday. And then so we have three here today, one about authenticating based on username and password, one for checking input length against the number of fields that are supposed to be associated with a table record. And then finally, one for hashing a password. So we'll see exactly where we got here. Now, you had said coming into this audit that you had replaced these print statements with something like this, right?
Yeah.
And then when you were using print statements, you said you were seeing both things print. So if we were to run this program now, you said that you would see first true print and then false would print, right? And if we look at our users table here that we have coming in, so Bob Jones, that's the person we're interested in, that's the name we're giving it. He's the first record in this table. And then the second one is Jane Wild, okay? So if we come back and we look at our application here, I'll tell you, there is a difference between returning and printing. And I'll ask a couple leading questions and we'll see if you can get it after that. Basically, with the returns, I think your function is correct with the returns. Now, I want us to go ahead and trace through this. Let's, we're not actually going to the debugger because we know the debugger sometimes has some issues here. But let's go ahead and trace through this just in our heads. All right, so when we call this function with this username and this password, at a high level, what we want to do is we want to go check in the user's CSV file here if there's a record that has that username and that password, right? And so you see here, we expect our function to return true with the inputs that you gave it because there is a person who has a username bob.jones and his password is password1. And those were the things that we passed our function here, right? So we expect the function to return true. So if we go through and we look at this code with the print statements, let's go ahead and let's trace the logic of how this program starts. So first, we're going to set a variable called field names equal to this list, right? And this will be the list of columns in our data. That's correct. And we're going to go ahead and open up the user CSV file for reading. And we're going to call it CSV file when we're using it with inside this with block here. And so once we exit the with block, if you remember back from yesterday, once we exit the with block, this file will be automatically closed for us. Python will do that for us. And then after we've opened the file, we open up a CSV reader and we use our dict reader method like we have been using here. So we are going to open up our CSV file that we just defined here for reading. And then we're going to use the field names that we just specified up above. So all of this is very similar to everything we've already done before. And also similar, we're going to go through all the rows in the CSV file, right? All of this, we've done all this before multiple times. All right, so now we get into the logic of our function here. So as inputs to this function, we had a username and a password, right? The user entered username and the user entered password. A little bit long variable names, but descriptive of what they are. All right, so we have a conditional here. So if the value for username in the row is equal to the user entered username, and the value of password for the row is equal to the user entered password, right now we have this with a print statement. We're going to print true. All right. So now I want to ask you, after we print true, what happens in terms of code execution?
Nothing. Well, I expect that the function stops executing at that point because that's the endpoint. There's nothing more to do.
So you say you think the function, I mean, I agree with you. The function should stop executing, but
yes,
remember, you probably heard me say this before, but computers are dumb, right? So computers obey us, but computers don't think for themselves. So logically, we say we want this function to stop executing once we printed true. Like if this function were supposed to print true or false rather than returning true or false, right? How we worded this was the function was actually supposed to return true or false, right?
Yes,
but if the requirements were to print it, then we would logically want to stop executing after we printed true, right?
Yes.
And actually, we wouldn't want to print false for all of them. But so here's the thing. If you wanted the function to behave like that, how do you stop? How do you basically break out of a function, right? How do you say, okay, I'm done?
With a return statement?
And if you just replace these returns here with print statements, do you have a return statement?
No, I don't.
Okay. And so you said you expected that once after this line, you said that you thought the program would stop. Actually, the program will not stop. What it's going to do is it's going to say, okay, we jumped inside this conditional here. This was true, right? So we're going to go ahead and we're going to print true. And then we're going to jump back up to the top of the loop. And we're going to say, for the next row in the CSV reader, what's the next row? The next row is Jane Wild, right? And then we're going to go ahead and then we're going to execute. This conditional will be false. We're going to enter the else here, and then we're going to print false because we didn't stop execution. You see?
Yeah.
So if you wanted to make this function print true and then stop executing, what you would do is you would make this a return. And then rather than printing false here, if we do this, we're going to print false for every single record that doesn't match. That's really probably not what you want. So you would want to break this out of the conditional there. And then if we get to the end of the function and if we haven't printed true, then we'll print false, right?
Yes.
Make sense? So that's how this would look if we wanted to do it with prints. But we really don't want to do it with prints. We want to do it with returns. And so since we're doing it with returns, when we do it with returns like this, now this logic is actually not completely correct. So it will work fine. It will work fine if the very first thing matches. Now, I want you to think about this. And so I've given you a hint. I said something is wrong about this. Think about what I just said with where we put the print statement for false. So if we trace through this code with Bob Jones, as we're calling it, we know that Bob Jones right now is the first record here, right? So it's the first row. And so having done all this stuff, we're going to compare the row username and the row password is going to match, and we're going to return true. That's great, right? That's what we wanted. But now let me show you what happens if we switch the order of these rows here. So rather than Bob Jones being first, let's put Jane first, like this, okay?
Yeah.
So do you agree that our function should still return true?
It should, but I think I see why it might not.
All right, well, let me convince you that right now, how we have it coded, it actually won't, right? Right now, if we do this, if we print the value of the authenticate function here, it's actually going to print false. And we'll see if you can explain why in just a second here. Is it running?
I'm not sure.
Huh. Let me try refreshing the page here. Oops, not the right file. It's being slow. Now, while we're waiting, maybe you can try to explain to me what you think the problem is.
Yes, I think like you said, when it checks the first entry in the file and it's not what we want, then it's simply going to return false and break out of the loop. That's what it will do.
That is exactly it. And so we want it to keep going across all of the things in the file, right? So here we said that this is going to return true. And I'm guessing it didn't persist my change there. Yeah, it didn't.
Yes.
Froze. But now if we put Jane first, so we just ran it with Bob first and it worked fine because he's first.
Yes.
But now if you run it with Jane first, this is going to become false. And that is incorrect because the information we're giving here for Bob is fine. But that's because, like you just said, how this works is we're going to get into the first row. The first row is Jane. We check, does the username for Jane and the password for Jane, is it equal to the stuff for Bob? Well, no, it isn't, right? So this is going to be false. We're going to hit the else, and then we're just going to return false. But we haven't checked any of the remaining records in the file yet, right? We only checked the first one. Mm-hmm. And so to fix that, to fix us returning the wrong thing there, we're going to want to put the return after we've checked all of the other things, right? So if we get to the end here, if we get past all this and we haven't returned false yet, then we want to return false.
Okay.
Because that means that we will have checked every single record. If we get here in the code, if we get to line 84, it means that we've gone through all of the rows in the CSV reader and we've compared the username and the passwords and none of them match. That's what it means if we get to this line here on 84, and then we return false. Okay, so we just said this was the wrong thing, right? Because we were trying to see if this information was there, and it is. It just isn't the first row. So now, having moved the return outside of that conditional so that it only returns after we've gone through all the rows, this should now return true.
Yes.
Does that make sense?
Yes, it does. It does.
Okay, so you were quite close on this one. All of the CSV stuff was completely fine. It just needed to move the return out a little bit there. All right, so let's look at this one now. Check if the length of values passed in is the same as the length of the list for the table name. If there's also given that we have this input dictionary here, right? So
I bombed this one. I'm still not sure what I was. I don't know. I couldn't figure it out.
Mm-hmm.
Then everything I tried pretty much failed. So
okay. So first thing is when you do this thing for dictionaries here. So did you ever? Yeah. Do you think that what you have works or?
No, I know it doesn't work. Actually, I wrote something different that I expected would work.
Let's start with this. I'm going to try to see if I can give you hints, and then we'll see if you can fix it as we go here. So iterating over a dictionary Python, right? So we have a dictionary here that contains, as keys, it contains the table names, and as values, it contains the list of the fields that the table contains, right?
Yes.
That's how this dictionary is set up. So what we want to know is what happens when you go through a dictionary. So blah, blah, blah. Let's find, you know what? Let's go to something that's more just like a reference resource, right? So right now, if you use a for loop and you say for variable name in dictionary print variable name, what this gets is it gets you the keys for a dictionary. Each X in this for loop is a key. And if you want to print the value in this, you would have to do this right here. So for key in dictionary, print dictionary indexed with the key. Does that make sense?
Yes.
Okay, so now if we come check what we're checking here.
Okay, I think I know what I got wrong.
Yeah.
Let me see.
So I actually much prefer, so I would do one of two things. So row here, row is not really a variable that I don't know exactly what you mean when you say row. So the variable name that I would use here is I would use either key or I would use table name. I would use one of those. It's actually perfectly okay to use key because as long as whoever's reading your code will be able to see what's in the dictionary and they'll know that you mean the things on this side of the colon. But usually best practice is to figure out what do these things represent here, right? The customers, store owners, and stores, well, that's a table name, right? And so if we change the variable here from row to table name like this, okay. So now let's trace through what your code is presently doing. So when we iterate through a dictionary, this is a dictionary, the actually tables here, I had it as an input. So properly speaking, if you use the tables variable right here, you're actually using the tables outside of this function. Whereas if we pass it as a dictionary, it's probably best to do that because we were passing it in as a variable here. I mean, it doesn't actually really matter here, but there you go. So right now, if we look at what this code is actually going to do, so we're going to go through all of the tables in the dictionary, and we're going to get the keys, which are the table names. And then what we check is if the length of table name, now what is table name here? Like what data type is it?
It's a string.
Okay, so we're going to check if the length of this string over here is equal to the length of when we index into the dictionary with the string table name. So does this dictionary have a key that is the string table name?
No.
Okay, so what's the first thing wrong with this statement right here?
Yeah, I had actually kind of turned it around the other way. I was thinking that I should have the tables outside of the function on the left-hand side. That was actually what I did. So what you have on the right-hand side when I wrote it was supposed to be what you have in the arguments themselves. So, but there is this is the major trouble I was actually having. How was I supposed to represent the keys in the tables dictionary without hard coding? I couldn't figure it out. I didn't want to say tables, then the key customers or store owners and stuff.
Okay, so do you remember how the reference we just looked at here says if you want to print all the keys in a dictionary, you do this, okay? So let's do that just to convince ourselves of that. So if we, right here, if we write this code, so we copy the loop statement here, and then we say we want to print table name. What do you think that our function will do here now?
Okay. Okay, I don't know what it would do, but I'm suspecting what it's going to do is it will print customers, store owners, and stores.
Okay. So you were saying you were having a hard time figuring out how to not hard code the keys, right?
Yes.
So do you agree that the variable table name here in the loop represents a key value?
Yes.
Okay,
Yes,
so if we run this, this is going to print out, it's going to print out customers. Well, it's supposed to if it runs. Why are you not running? Oh, our online IDE is
been having trouble. It's been having trouble today. I reloaded it so many times and
maybe we should soon then, maybe we should move into local development with Visual Studio Code. I'll have to help you get set up with that. But it might be a good idea for us. And if we're having issues here.
Okay.
I was kind of putting it off because if we don't share code like this, we're going to have to learn how to do version control at the same time, which is an added level of complexity and stuff. But I mean, you're going to have to do it at some point. So yeah, this is really not working though. There we go. Well, that is
that's weird.
Oh, well, you are not. I see. So
Okay,
what
that's
it's because of what you're passing it here.
okay.
This is supposed to be. So what are you passing it right now?
Okay, I'm passing it that string tables.
Now, should it be a string?
No, I'm not sure. Really, I'm not sure.
So how do you call a variable in code? Do you call variables as strings? Like if you want to pass a variable to a function, do we put the name of the variable
in the string? No, we don't. How did that get in there though? Weird.
Okay, so if I do this, what is this then?
That's a variable.
That's a variable. And what value does that variable have?
It holds the dictionary, or rather it is a dictionary with the
it's all this stuff, right?
Yes.
It's all that stuff. So this is how we want to reference this. We want to pass it, we want to pass this function the dictionary that we're passing it. Okay. So now if we do this, it shouldn't print the letters in the string. This should actually print the names of the keys in the dictionary. There we go. That's what we expect, right?
Okay.
All right. Okay. So let's ignore what you did down there for the time being. Now that you know, if I want to access the keys for all the records in the dictionary, for each thing inside this loop, table name contains the key. Okay, so given that information, we want to check if the length of the values that we're putting in for the table name here is equal to the same thing as the length of the values for that table, right? For the length of the fields. Okay, so walk me through. What's the first thing that we should check here? Before anything else, we know that we only care about the length of the fields for a specific table name, right?
Yes. So if the table name is equals.
Yeah, so we probably ought to pick a different variable name here, right? So you see how right now we're taking in a variable called table name, and then we're using the loop variable called table name as well, right? Yes. So I would actually probably have us, what's the best thing for this? Well, we can just call this variable table, right? That'll work fine. So this represents the key value in this dictionary, because whenever you iterate through a dictionary with a for loop like this, what you are iterating with is a key. Okay?
Yeah.
So now what should we write here?
We can say table name, right?
With table name, what?
Equals table.
Okay. Yeah. So now what this gets us is we're only going to care about whichever record we match on the table name with, right? Yes. Okay. And what we want to be checking is if the length of our inputs here, so that's not the only thing we want to check, right? We also want to be checking if what?
The input values match. Okay, so length of input values.
And what should that match?
Equals, I would say table, then brackets, square brackets, no parentheses, I don't know what it's called. So yeah, then wait, I think I'm getting something wrong.
So we want to index into the dictionary, right?
Yes.
So what is the variable name for the dictionary?
Tables. So tables.
Is it tables or is it tables dict inside of this function?
Okay, tables dict. Okay. Okay.
And what do we index into dictionaries with?
Tables.
Well, I mean, we index into dictionaries generally with keys, right? And each key here happens to be what? What's the variable inside of this loop representing the key?
Okay, is table name? I mean,
is table name the key in this loop, or is table name what we passed in as a string to the function?
Table is the key table.
Because for key in tables dict, right? That's what we're doing here.
Yes.
Each key represents a table. So the variable for our thing that we're checking here is going to be table.
Yeah.
Okay.
Yes.
So our conditional is if the table name is equal to table, right? So the table name that we're passing in, if it equals the thing that we're currently passing in, and you normally, actually, I would probably order the logic of this in reverse like that. I think this probably makes more sense to most people. So we're going to check if the key of the row in the dictionary that we're currently on is equal to the table name that we're checking, right? And then that the length of the values that we passed in is equal to, now we're missing something here. We're checking, this should be a number, right? Like an integer.
Yes.
What are we missing over here?
Yeah, we're missing the length there too.
Okay. And if all that's true, then what?
Return true.
Okay. What happens if we make it through all of the things in the table and we haven't found anything?
Yeah, we return false, but we unindent to the level of,
So we don't want to do an else here, because then we have the same problem we just had above, where we return false on the very first one and then we don't check any of the others. So we only want to return false if we exit this loop and we've checked all of the records in the dictionary, right?
Okay. So it was just this bit, the for and if statement, that was what confused me. I didn't know how to represent the tables or the keys in the tables dictionary. Yeah, so I think it makes sense now.
So you remember this website, right? We're on W3 Schools, and it has a bunch of different programming languages. Right now we're learning Python. So you go over here in the sidebar, you click on Python dictionaries, and then there's all these sub things here. Loop dictionary.
I mean,
right?
I did know how to index into the dictionary. I just didn't know what to call the key. So I was pretty stuck on that. I didn't know if I was just supposed to have an empty string in there or call it something. I didn't know. I didn't want to hard code it, but I didn't know how to represent.
So all sorts of ways here. So if you just use the name of the dictionary variable, by default, you get keys. And you can get values by indexing into the dictionary. You can also iterate directly over values by calling the values function on a dictionary like this. You can also be very explicit and get the keys. This is functionally the same thing as just saying this dict, right? But if you do this dict.keys, then in your head, you're like, oh, this is 100% going to be keys, right? And if you want to get both keys and values at the same time, you use two variables in your loop like this, and then you use the items function.
Right.
You think you get all the permutations here? So if you just have a dictionary, you get keys. If you want to act as a value, you can just index into the dictionary in the keys loop. This is what we just did right here, right? If you wanted to get the keys, and if you wanted to get just the values, you can call the values function here. And then this will return a list of the values in the dictionary. And if you want to do keys, but you want to be explicit, you can call keys. And if you want to use both key and value, you can use items. So this loop is basically, Python doesn't have a separate loop type. It doesn't call it a for each loop. So you can iterate over indices using the range function, if you remember that. So you might do something like for I in range of, and then we give it a range function, which all that does is it builds a list of indices, right? But for loops in Python are all what other programming languages tend to call for each loops. So for each item in this collection, right? And so here,
Yes.
each item represents a key to this dictionary, right? And so every time we go through this loop, this value is going to get updated. Table is going to represent a new thing every time we do a new iteration.
Yeah. I get that now.
Mm-hmm. All right, so let's test ourselves here. So this is the call we're making now. So we have something. This should be the same as the length for a customer's record. It's in the same order. So we're checking the customer's table. And we expect this here to now return true, right? So let's wrap this in a print statement. Expect this to return true. Awesome. Now, if we were to change this table to store owners, is this going to have the right number of fields anymore?
Nope.
Because store owners have assets and liabilities, right? And customers don't. So these things don't have the same length. Now it's false, right? Means that we're checking things correctly.
Yes.
Okay. So last one then that we had here was hashing something. So you want to tell me what you Googled and we'll see if we can find the same thing that you were working off of?
I Googled the string you gave me, how to hash a string Python. So I did that and I got a link that told me how to, first of all, I had to import the hash library.
Mm-hmm. Do you know which link in particular you were using?
Yes, let me see if I can pull it up. So this link here, I don't know if it's showing.
What is here? Okay, you copy pasted it. Yep, gotcha.
Yes.
Python Central.io. Yep, that was the first one on my string too. All right, so hashing strings with Python. Ooh, it's got a description too. Okay, so we're going to take in a string and then we're going to apply a hash function to it. And coming out of that hash function, we're going to get a value, right? So it has some background information. Most used hash functions, MD5 and SHA or SHA, both very common. So you'll hear these too. So there's a library in Python called hashlib. So hash library.
Yes.
Okay, so we import hashlib, and then I suppose you can check which algorithms you can use to hash and some other stuff. If you use MD5, you call it like this. If you use, which one did you use? So you used...
I used one of the SHAs.
Mm-hmm. So 384.
Just copied one of them. Yes.
Yep, like this. Okay. And so for this function here, I mean, everything you did is fine. So hash object is equal, we're going to hash this thing. Now, do you know what the B does?
Yes, it changes the string into a sequence of bytes.
Right. So it's what this says right here. It's important to note the B preceding the string literal. This converts the string to bytes because the hash function only takes in the sequence of bytes as a parameter. So if we had a typed programming language, we would say that this thing is an array of bytes. Do you know what a byte is on computer systems?
Yeah, that's 8 bits. That's basically a series of ones and zeros.
Yep. And that's what we're going to leave it at for now. Bytes are used to represent data on computer system. I mean, bits too. Everything is ultimately traceable to ones and zeros, right? But for us, it's not that important to know that basically this function, we need to take our string and we need to convert it into just ones and zeros, right? So-called binary string. right? So it says previous versions of the library actually used to take in a string, but not anymore. So now we just need to convert it to a byte. The easiest way to convert a string to a byte string is just to put a B in front of it, like this. Very simple, okay? So that's why we pass this function of byte string, and then we get a hash object. And then, what does the digest do exactly? Let's see.
Okay, that one is not very clear to me.
Prints the hex digest of that string. Hex digest returns a hex string representing the hash. In case you need the sequence of bytes, you should use digest instead.
Hex string, so it returns a hexadecimal, right? Rather than a normal decimal or anything. Okay, so if what we want instead is a sequence of bytes, then we just use.
Now, if we're storing something in the database, we actually probably don't need the sequence of bytes. It's fine to use the hex string. So we don't need to get too off in the weeds here. Either one of these, I'll show you. We'll print both of these here. So let's.
I do have a question though.
What'd you say?
I do have a question about this at some point though.
Okay, sure. All right, go ahead. You can ask your question.
Okay, so they said it's that it's not really how did they put it in that thing? It was more like this is not a way to secure a password or something other to secure information. No, I was a little confused by that.
Like this one, let me read it a little bit. Salt is a random sequence before using hash function. Which part exactly are you talking about? Was it this paragraph at the bottom?
No, not that one. Not that one. I will soon find it. So, okay, yeah. So it's the second and third paragraphs. Particularly the third paragraph, I want to make clear that hash functions are not a cryptographic protocol. They do not encrypt or decrypt information, but they're a fundamental part of many cryptographic protocols and tools. Yeah, so I wondered, what was the point then? I mean, you have to use these in addition to other things to encrypt and decrypt information. Is that the point?
So good question. Actually, cybersecurity isn't my expertise. So let's see. Are hash functions good for encrypting passwords? Let's do some research. So it's a good question. Hashing versus encryption. Hashing and encryption both provide ways to keep sensitive data safe. However, in almost all circumstances, passwords should be hashed, not encrypted. Hashing is a one-way function. That is, it's impossible to decrypt a hash and obtain the original plaintext value. Hashing is appropriate for password validation.
So that guy wasn't completely right?
Perils of trusting people on the internet, huh?
Yeah.
So it's a good question. So encryption and decryption, hashing is one way. This is the best way to think of it. We don't actually care what the user's password is. Like, we're never going to go through the database and, I wonder what string the user actually used for that password. As long as we always use the same hashing protocol, when the user enters a new password, we'll hash the password that they entered and we'll see if it matches the thing that we're storing in the database, right? And if it does match the thing that we're storing in the database, then we'll authenticate them. And if it doesn't match, then we won't. But we don't actually care what their password is, right?
Okay.
And so why this is important is because if someone gets your database, if a malicious user downloads your whole database and they have all of the information that we're storing as a password in the database, all they're going to see, I ran it, all they're going to see is this, right? So when we have the hash object here, this thing must be some internal memory like representation of a hash object, right? You see this right here? It says a hash object. This is how Python signifies that this thing's an object in terms of object-oriented programming, right? Okay. So it looks like if you want to get the actual string text value of it, you call the hex digest function here on the hash object. And this prints it all out, prints out all the hex values as a byte string here. This is what we would store in our database. So you see here in our customers file, right now we're storing things as like actual password 1, password 2, and so on, right? But in a real world system, we don't want to store what the user is saving as their password in plain text, because then if someone gets our database, they may take that user password that we have there, and then they're going to go try it. So they may take the user's username and password, and they may go try it on other websites. And what happens if that person practices poor cybersecurity practice and they use the same username and their password for their bank? See what I'm saying? Yeah. Now suddenly that person got their bank account hacked because our system got hacked and we didn't hash the password. And so what I'm saying is that if someone hacks this system and they get that Bob Jones has a password of password 1, and then they go try that, they try to log into his bank as bob.jones with password 1, and then, oh, wow, they actually got in, right? That's really bad. But if this is what password 1 hashes to, and actually we don't have to guess, I can show you. So let's say that when Bob is registering, he actually does register with password 1. So we're going to run it through our hash password function here. So we're using SHA-384 hashing, right? There's different, you can set different levels of bits here for the SHA functions, but we're using SHA-384, and we're going to pass in, well, actually, question. So we would expect, you see, this is what we had right here, right? When we run this function again, should this be the same?
I suspect yes.
Do we want different passwords to hash to the same thing?
Okay, did we change the password just now?
We did.
Okay.
Previously, this was my underscore password, and now I've changed it to password 1. I haven't run it again. So this is what the value my underscore password when we pass it into this function returns. If we give it a new password, it shouldn't return the same thing. We should be hashing it differently. But if we do run it,
it won't return the same thing.
But it did just return the same thing. So I want you to look at this line again. So remember how we were saying up here, remember when you were passing tables as a string here, right?
Yes. So, but the problem I had with it was if I didn't make it a string, how could I pass it there? I wasn't sure how to pass it there without making it a string.
How to make something a byte string, right? Is that the problem?
No, I mean, I passed in password at that, right. Right. So, yeah, I see. I mean, you just put in curly brackets, right?
So
that's how.
Let's Google Python. Well, that's how you do it if you're formatting a string. So-called F strings in Python lets you format the string by injecting your variables. But Python, how to convert a string. So if you're just assigning it, if we're just assigning it from like as a new string, this is how you can get a byte string. You can set a variable equal to this. But if you already have a string and you want to convert the string to a byte string, we probably actually need to call a function to do it. How to convert strings to bytes in Python. Sounds like what we want, right? We can use the built-in bytes class. So let's see if there's anything that lets you specify the best way to convert strings to bytes in Python 3. So, ooh, Pythonic. So looks like we're going to use bytes here. So some string and encoding. This is how we call this function. We're going to call the bytes function here. And then we're going to pass it our string, and then we're going to pass it how the string is encoded. Now, most strings that we would have for passwords are probably going to be ASCII. So have you ever heard of ASCII before? ASCII?
Yeah. Yes.
ASCII versus UTF-8. So let's read this. Ooh, it's a blog post. So this is how computers represent characters. If you are interested in how computers represent different characters, Unicode characters can contain letters from other languages, like the Greek alphabet, for example. In fact, I did. Ooh, let me go find it. I have an open source project that I wrote in college. So this was as close as I had to an undergraduate thesis in college. It's like a 32-page paper or something, research paper that I wrote when I was designing a keyboard layout for ancient Greek. And we dealt with Unicode characters here. You can see Greek letters. So that was the first hit on Google. I actually have a GitHub repository too. Well, I haven't refactored away from my old project site, but yeah, so, you know, has an encoding for Greek letters. All I'm telling you is that I've dealt with this quite a bit in computers. And if you want to go look at what this looks like code-wise, where are we? Greek. Go find something that does like the Unicode composition here. So I'm using Unicode inside of my code itself. So I have a lot of logic here. You can see just a lot of conditionals with keeping track of if they press like an accent key, what key do we send back with the accents and stuff. But this is what Unicode and ASCII and UTF-8 comes from. So all this a long way of saying when we are encoding something into bytes, we need to know what is the encoding of the string that we're using here. So most of the time for passwords, you know, ASCII, the ASCII character set. So if we Google ASCII character set, it's going to look something like just, is this table? This table's fine. Oops. Let me open this in a new tab and then we'll make it bigger. So this is the ASCII character set. Now, stuff that is more normal to us, like you see letters over here, capital letters start at the hexadecimal value of 41. For now, don't worry about the difference between decimal, hex, and octadecimal, because you can convert between. These are different base number systems. So you may have heard that our counting system is base 10, right? So-called decimal. Well, I think it was the ancient Babylonians. They used a base 64 number system. Very interesting. I'm not going to get into the math behind this. It's quite interesting number theory stuff, but basically computers tend to store things as hexadecimal. I mean, computers store everything as binary. So binary is base 2, hexadecimal is base 6, oct is base 8, and decimal is base 10, right?
Okay.
So the hexadecimal value for the character capital A is 41. The hexadecimal value for character lowercase a is 61. You can see the decimals for this are 65 and 97 respectively, and so on, right? So this is the ASCII character set. Now, assuming we are only letting people use ASCII in their passwords, we could have the encoding come in here as, where are we here, right? Best way to do conversion here. So if we go and we look, here's a UTF-8, because ASCII is a subset of UTF-8, UTF-8 implements ASCII and then some, it's probably safest to always just use UTF-8 for your character encoding. Because that way, if someone uses some weird Unicode character in their password, your program won't just error, right? You'll handle it. Does that make sense? So this is what we want to do right here. So we're going to go to our program. We just learned some about hashing and passwords and stuff. Okay, so this would be if we're manually specifying a byte string, but we're not manually specifying a byte string, right? We want to convert a string to bytes. Oops. Oh, it looks like that didn't copy quite right. Copy. There, bytes. And rather than my string, what's our variable called here?
Password.
Password, right. Okay. Now, if we run this again, now that we're actually hashing the variable, this shouldn't be the same anymore, right? Ooh, it changed. See that? Does that make sense? And now if we change this from password1 back to my underscore password, this is going to convert internally, it's going to convert to a different set of hexadecimal, right?
Yes.
See, changed again, right? Okay, so now we're properly hashing the passwords. What we've done makes sense?
Yes, it does.
Okay, and so at the end of this function here, we can just, well, I would just say, let's get, it's a little bit more descriptive for us as humans, right? And then we want to return the hash string like this. And now this function is going to return the string. And so properly speaking, if we return the string, then we want to print the string like this. And that would be how our function operates now. All right, so hopefully this has been kind of an interesting introduction to you to the idea of computer security. So in fact, one of the widest growing areas in computer science is called cybersecurity. And there's a lot that goes into securing computer systems and preventing attack vectors and protecting systems and stuff. It's a really big deal, especially if you work in the government sector or for banks and things like that. You don't want people to get hacked and lose their information. And I will say that popular culture, movies and so on, they kind of get this all wrong. Someone does not just sit there and type really fast on the keyboard and break into a computer system. That's not how it works at all. In fact, there's actually software that has been written to break into websites, right? So we might use our programs like browsers or text editors or spreadsheet programs or whatever. Well, people who are nefarious users, so-called black hat hackers, well, they have special software suites that they run code, they run libraries and stuff to try to break into websites. Now, you got to be really careful. Actually, hacking in a nefarious sense is even if you don't do anything with the data, if you breach a government system in the United States, you'll face jail time. It's illegal. Like just the act of doing it is illegal. While some of these, so there's a Linux distribution. It's called Kali. I think I spelled that right. Kali Linux. This is Linux, of course, is it's an operating system. You may have heard of the Linux kernel, very famous. In fact, Android is basically a flavor of Linux. So I won't get into it. Mac OS, it runs on a form of Unix called Darwin. That's the underlying kernel architecture for it. Now, Linux is also a form of Unix. There's standards in programming called the POSIX standard. I don't want to get too off in the weeds here, but Kali Linux is a Linux distribution that deals with cybersecurity stuff. And so you might deal with penetration testing, right? That's seeing if websites are secure, seeing if you can breach them. Cybersecurity research generally, computer forensics, also reverse engineering. So you can run these things like decompilers and stuff that will let you try to see what the code is. Cybersecurity, if you're interested in it, very hotly expanding field. On the other hand, it's kind of not where you want to start. It's pretty complicated. So people go to graduate school in this. People who have the highest paying jobs and stuff, people in this field, depending on who you work for and how good you are and whether you're doing research and stuff, may make hundreds of thousands of dollars every year. It's competitive too, of course. But some people find it really interesting. This is probably, I'm trying to think about the best way to put this. This is one of those like elite fields in computer science. So there's kind of a division between what I would call like the normal garden variety computer programmers who know how to make business software and, run with databases and that sort of thing. And then there's like I call them hotshot programmers, right? The cybersecurity guys who write PhD theses on like breaking into computer systems and cryptographic algorithms and stuff, it's really complicated. Those are the hotshot programmers, people who are super geniuses. Not everyone is. There are more garden variety jobs in the field as well, but it's really interesting stuff. So if you're interested in it, lots of money there. Also very competitive though. So there you go. We're not going to spend too much more time on hashing and passwords and cryptography here. Hashing is used commonly in cryptography. Encryption and decryption algorithms use hashing because that's how they do it. They have hash cycles, and we won't get into all the specifics of it. But at any rate, we got into all this because eventually, if we want to have a secure application, we want to store passwords as hashes rather than the passwords themselves. So that's as big a tangent as I'll go on here for now. But hopefully it's at least somewhat interesting, right? Gives you a real taste at the wider world here of programming.
Yeah.
Okay. So questions on the practice problems that we've had here?
Just that I'd like to have another practice problem on the second one.
So the second one was dictionary stuff, right?
Yeah.
So you want something else relating to dictionaries and looping through dictionaries and things like that?
Yeah.
Okay.
I want to see how well I understood what you did, what you explained.
Okay, so I can do that. Get that one coming up. So I was thinking the other day too about, we talked some about how we want to be structuring our time. And we talked about 2 hours. I kind of want to play it by ear a little bit and see how long it takes us. 2 hours is actually a very long time every day. So what I was thinking was it might be more productive for us to basically spend the time that we have together going through the problems that I give you, and then I'll give you more problems. And so most of the time that we'll spend on the videos recording like this will be kind of going over the practice problems directly. And then every once in a while, we'll go through a new topic where I'll more formally like do a teaching session. But I'm not sure that I want to try to cram, both things into every single lesson so that we're on the call for 2 hours every day. It's just a lot. For our part here, maybe we spend another 20 minutes or something today working on the main programming loop. And then I will try to leave you some homework relating to that in our application directly here, perhaps, and give you another practice problem with dictionaries. But just want to make sure that what we're doing is on topic, and also, of course, this is on top of me working 8 hours a day during the week anyway. So if I do 2 hours of programming and 8 hours a day at work, and then I work out and take a shower and eat dinner and lunch, I have no time. I'm thinking maybe we'll try to just keep it to mostly going over practice problems. We'll still make it a daily thing. And then however long it takes us to go over the practice problems, and then I'll give you a new set before the next day. That way you'll have lots of heavy practice. And I think that'll probably be the most efficient way. That'll be the plan here. So with that out of the way, I will try to spend the rest of our time here this afternoon going through how we want to set up the remaining work to do here on the main program loop. So if you're ready to switch gears a little bit, we're going to come back and we're going to be looking at the main method that we'd started writing here for our storefront application. So where we got here was we decided that users have a type. Where are we setting user type? I guess right now we're not setting user type, but eventually we will in the login function, right? Returns user information, which includes a user type, right? And then if you remember back, we were thinking about the best way to handle only some kinds of users can do some things, right? Do you remember the conversation we were having here about this?
Yeah. Like only store owners can access the stores, and maybe stores that products, for example, they would actually put products. And
they're the only ones who can make like orders to replenish the inventory or acquire other things and things like that, right? So only some people can do certain kinds of things. Now, are there going to be operations that will be shared across people?
Yes, because customers can see in inventory. They can see what's actually in the stores. So can store owners. And well, I think this is a bit different because store owners can also be customers. So yeah.
Okay. So basically, at any given point in time, a user could be a customer or a store owner or both, right?
Yes.
And I think something that'll help us think about this. Remember, we had decided, we could store a user type as an enum, right? We could say they're a customer or a store owner or both, like this, right? So before we get too ahead of ourselves, I kind of started doing logic with that. How about we think about options that we can display to the user? So the very first thing we do is we tell them they need to log in. At this point, we said, if you have an account already, please log in. Otherwise, please create an account, right?
Yes.
And so you see how this first print statement we have, what would you like to do? Well, the user will have to know that they need to type the string login. But you see how thus far, we haven't actually told them that, right? We haven't told them the things that they can do. Your options are, okay. So right now, how are we going to do, how are we going to give the user the options that they have? We don't have anything set up to do that yet, right? So how about we set up a variable called, well, actually right here, right here, this one specifically before they're logged in, their options are those two things, right?
Yes.
Log in and register. So let's use our quote type here. We do that. Your options are login and register. Okay, so then the user inputs one of those two things. They can log in here or they can register. And if they don't enter one of those two things, we tell them to please enter a valid option and try again, right?
Yes.
Okay, so in our main loop here, this is the first print statement that we're going to have. But how about we write a function here for to take in, we're going to say get possible user actions. Okay, so we're going to take in a user type. Now, what are the values for user type? We said that user type is this thing called an enum, right? Do you remember what enums are?
Not quite.
Okay, so an enum is basically where you have something that is going to be chosen between a finite set of values, and you basically want to give each value something in code that you can reference it by. So we say a user has a user type. The only three user types that are possible are customer, store owner, or both. There are no other user types. So you might say, well, Stephen, we could just use a string for this, right? Couldn't we just say user type equals customer as a string or store owner as a string or both? Well, you could, but the thing is that in your code, that's more error prone because what happens if you misspell something? The compiler won't tell you. Whereas here, if we have a user type and we try to say that the user type is something, like I'll show you, okay? So we can say if the user type is our enum, and then we say that it's a customer, like that, right? So this is valid, right? This is one of the user types. Let's say we misspell it. Well, okay. Right now, this is downside of Python. Right now, nothing bad happens. In compiled languages, it wouldn't even let you run this program because this is not a valid value for this enumeration. So I guess maybe it's not as big a deal in Python. I use these things all the time in C# because you want to value check yourself. This is for us as programmers. The user doesn't care. You could do this with the string just fine, and then like do if, elif, else on the string values. But if you use an enumeration like this, it makes it harder for you to mess it up in the code, for you to use a value that doesn't exist or things like that, because you're choosing between a finite set of values. Okay, so if the user is customer, we want to return a list of all the things that customers can do. So let's go find, we've written all this up at some point here. What can store owners and customers and stuff do, right? We had a comment, right? We said customers, store owners can do this, customers can do this, right? Let's go copy all this up here. Yeah, I mean, this file's gotten quite large, hasn't it? All right, so we're up here writing our get possible user actions. Let's paste the stuff into string up here. Okay, so store owners. So we're looking at customers right now. We say view product, right? That should be an option for them. So we could say customers can view products. Okay, that's an option for the particular store that they're in. Now, properly speaking, they can't view products until they've picked a particular store to look at, right?
Yes.
Does that make sense? So it's not just going to be user type that we're interested in here. We're also going to have to track state in our application. So are they looking at a specific store or not, right? But for now, let's just get things that the user can do. So we want to be able to let the user view stores, right? Because logically, before they can pick a store, they need to be able to view stores. So they can view stores after they've viewed stores. We want to let them basically select a store, right? Select the store to look at. And having selected a store, we want to let them go back to the view stores, right? We want to let them go back to the store view. But after they've selected a store, that's when they can view product, right? And after viewing products, we want to let them add a product to their cart, right? And we want to let them remove a product from their cart. All these things sounding like normal store application type things, right?
Yeah.
But you see how big this is getting just right off the bat, right?
Yeah.
Okay, and then we want to let them deposit money to their customer. Okay, so right now we're just tracking in a big list here. But some of these things are going to depend on where, like what path they're in the application, right? Okay, so that's store owners. We'll just start with them. Now we'll come back to this and clean all this up, I promise. You know, right now we're just trying to get stuff down in code to get ourselves thinking about it, right?
Okay.
So how about people who are
Use the enums you talked about. Why don't we use the enums you talked about?
We are using the enum here.
Okay. I mean, I think you said it was best to not use the string that you're typing.
But we're not using the string.
Okay.
Is this a string right here?
Oh, no. I thought you would be using 1, 2, 3 or something like that.
So what we're doing is the enum values represent the values of 1, 2, and 3. But
okay,
if I tell you that user type is equal, to 2, what does that mean? You see the problem?
Okay.
This is exactly the purpose of enums. We want to let the user pick between a finite set of values, but it does us no good in terms of rating our own code if we say user type equals 2. I have no idea what that means, right? But if I say user type is equal, if I say that user type instead is equal to user type dot store owner, I see, okay, this is an enumeration and we're picking a single value of that enumeration, right? It's much more descriptive for us. Okay. So, let's clean up the display here a little bit. You may see this. We're just going to return this list on multiple lines. That way it'll let us style it in the return. So these are all the things that we decided customers can do. We might add or remove a couple here or there as we go on. Okay, so those are things that customers can do. View store, select a store, go back to view stores, view products, add a product to their cart, remove a product from their cart, deposit money into their customer account. Actually, we should let them check out too, right?
Yeah, we should.
I think that's pretty good for now. Store owners, what can store owners do? Okay, so up here we said that store owners should be able to see products and store inventory. Well, we said store owners could pick a store, right? So we want to let them view their stores because they might have more than one, right?
Yes.
We want to let them view their stores. We want to let them select a store, although what that means for them is a little bit different, right? We want to let them order products for the store.
Yeah.
We want to let them order products for the store inventory. We want to let them close the store, right? That's possible.
Yes.
Now, we also want to let them open a new store, right? Also possible. Maybe we can say, like, view balance sheet, and that will be assets and liabilities for the store, right? Does that seem like a pretty good start here?
Yeah, it does.
Okay, so before we even get here, right? So what we would want to do is there are some things that we are going to want to do before. So regardless if the user is a customer or a store owner, how about this? How about we set up a variable here for like valid operations, and we're going to set this equal to an empty list. And then let's say how to add values, how to add multiple values to a list. Aha, so you can't just concatenate lists like this. So remember how we said concatenation works on strings?
How? I didn't catch what you just said.
So I said, do you remember how concatenation works on strings?
Yes, yes,
so
I do.
It looks like you can concatenate lists in Python too. So if this is an empty list, then what we're going to do here is we're going to say valid operations, we're going to say is equal to the valid operations we already have. And then we're going to add some more, right? Like that. And then we're going to do the same thing here. Now, we decided that now we got to think about this, right? If users have a user type of customer and store owner, right? Because some people might be both, right? Are you still here? Hello? So we need to think about what happens if they are a customer or a store owner, and what things do we want to do regardless of if they are a customer or a store owner, right? So right now, we know that, how about we do it this way? So we have some customer operations, right? We have some store owner operations. Over here. Okay, so a user can only have 3 types, right? They could either be a customer or a store owner or both, right? Yes. So we want to make sure that they end up with the right set of operations. So if we have an else here, this else represents the case where the user type is equal to what? So there's only 3 possibilities. If they're not a customer or a store owner, what else are they?
They're both.
Here. They're both, right? Okay, so in the both case, so we said for the customer case, we only give them customer operations. For the store owner case, we only give them store owner operations. How about the both case?
Give them both operations.
Mm-hmm. So all we're going to do is we're going to, actually, we don't even need, we're not even going to concatenate like that. We can just straight up set them equal to this. So we're going to say that we're going to have both. So they're going to have, that's not what we want, customer operations plus store owner operations, like that.
Yeah. Okay? Yeah.
All right. And finally, after all of this, there's some things that all users can do, right? Yes. So we're going to say customer operation, store owner operation, then we're going to say all user operations. Those things might be like, for example, they might want to change username, right?
Yes.
How about change password? Maybe delete the account, right? We'll let them delete their account. What else? Change name, I guess, right? That's a reasonably good start, right?
Yes.
Okay. So these are things that we want all users. So you agree that after this conditional is run, what values will the variable valid operations have? It's going to depend on, we may as well just make this. We may as well just make this explicit. So it's got to be one of these 3, right?
Yes.
So after this runs, they're either going to have customer operations, store owner operations, or both, right? But regardless of the values that get set here, you want to give them all the user operations, right?
Yes.
Like that. Does this function that we've written make sense?
Yeah, it does.
So we're going to take in the user type. We're going to start out by building a list of the things they can do. So the customer can do these things, the store owner can do these things, all users can do these things. And so they might have the total set will either be customer plus all user stuff, store owner plus all user stuff, or customer and store owner plus all user stuff for those 3 cases respectively, right?
Yeah.
Okay. So this slightly helps us in terms of what we had here, right?
Yeah.
Now, this should simplify the logic. Why I had us do this is because this is really straightforward, right? It'll make it really easy for us to maintain over time. Say customers can do these things, store owners can do these things, right? And then eventually we'll write functions for each one of these things. But remember how we were having kind of a hard time figuring out what we wanted to do up front, right? So in our main loop, if the user inputs exit, we break out of the loop, right? If the user type has not been set yet, we don't do anything, right? So once they log in, we may set the, we're going to say user data. So let's make pretend that login returns user data, which it will. And then we would set the user type here by doing like user underscore data, right? And then we might, if that's a dictionary, for example, we might access it something like that, right? So after they log in, they have a user type set, right? And after they register, upon registration, we'll also have them return user data. We're just scaffolding out what this will look like eventually. We haven't written any of these functions yet, but let's make pretend. Okay, so before they have a user type, this is what can happen. And so after this, we're gonna have an else. Okay. So in the else here, that means that the user type has been set, right? So we're gonna get rid of all that stuff because now we're gonna be checking things based on the list of operations that we have, right? So at this point, we've decided that we have this variable for user input, right? So now what we want to do is we want to check if what they've entered is valid, right? So the very first thing we can check is if user input is in, and what should we do? We should probably call this one based on the user type, right? So this function here returns a list of possible actions based on the user type, right? So if that, then for now, we'll leave it at that. But if it's not that, then we want to print this, right? Does that make sense?
Yes.
All right, so let's look at our main program from the top. First thing we're going to do, we're going to set up two variables, one called user type, one called user input. We're going to print this, welcome to the storefront. If you have an account already, please log in. Otherwise, please create an account. And then we say, what would you like to do? Your options are login and register, right? And then register should also say exit, right? Because that's an option too. And exit. So if they press exit, we say goodbye, we break out. Otherwise, you know, we do all this. We don't actually care about that null user type for now. It doesn't actually give us any useful information. So actually, yes, we do, because that is controlling this else here. So if they don't have a user type yet, it means that they're not authenticated. So then they either need to log in or register. If they log in, at that point, they get a user type. And then the next time through this loop, we'll skip this if, right? And we'll hop down here. And after that, we'll check if the operation that they've given us is in the possible list of actions that they could take, right? And if it isn't, then we'll tell them they need to pick a valid operation. Are you tracking so far?
Yeah.
Okay. So I'm trying to think about how much more we want to get done here tonight. So this is a good start on how we're going to be setting up the process here, right?
Yeah.
So I think this is a decent place to split. Maybe we'll cut off here, and then tomorrow we'll pick up. We'll keep going on our main program loop stuff, implementing some of our actual functionality, right? Does it sound like a plan?
Yeah, it does. Sounds like a good plan.
Okay, so that's where we'll stop for today, and we'll pick up with that tomorrow then.